Hello students, welcome back. This will be ionic nomenclature, which is the naming of chemical compounds that deal with ions. And the way you know something is ionic is if it's a metal to a non-metal. If you remember from the last lesson, if the element was on the right side of this staircase, it was a non-metal, and then plus hydrogen. If it's on the left side of the staircase, then it's a metal. Now there is a particular group of metals that we'll focus on, the transitional metals that are found in columns 3 through 12. They'll have a special rule set for them later on, which we'll get to. Something else to note is the ionic charges. At the top of the periodic table, I've put the charges commonly found for those ions. So this first column of elements, it typically has a +1 charge. Column 2 has a +2 charge. Column 13 has a +3 charge. Column 15 is -3, column 16 is -2, and column 17 is -1. And that will come into play a little bit later on. You'll also want to know the names of common polyatomic ions. There are tables and lists available of these online that you might want to download or print. Here are a couple listed for you. For example, SO4, that's called sulfate. PO4, that's called phosphate. NO3, that's nitrate. OH is hydroxide. CO3, it's carbonate. C2H3O2, sometimes you may also see it as CH3COO, that's acetate. ClO4, that's perchlorate. NH4, that's ammonium. MnO4, that's permanganate. So those are some of the common polyatomic ions you'll see. There are a great deal more that you'll want to familiarize yourself with. So you'll also see different versions of these polyatomic ions, like SO4 is sulfate, but you might also see SO3, which is sulfite. In that event, you'll have to recognize the difference and know how the nomenclature works behind those. If you see a ATE ending, that means it has a greater amount of oxygen relative to its other versions, and an ITE ending has a fewer amount of oxygens in comparison to the other versions. And if it's one more oxygen than the ATE ending, then it gains a prefix of per. And if it's the least amount of oxygens in comparison to the ITE ending, then it gets a hypo prefix. For example, I got the class of polyatomic ions with chlorine and oxygen. All of them have chlorine and oxygen, just the amount of oxygen varies. It goes from 1 oxygen all the way to 4 oxygens, and those names will vary for it. So ClO, that is hypochlorite, ITE ending because it has fewer oxygens than the rest, and hypo prefix because it has the fewest oxygens. It only has 1. ClO2 is chlorite. It has an ITE ending because it has a fewer amount of oxygens than the rest of them in comparison, but not quite as few as hypochlorite. Next we got ClO3, that's chlorate. It has an ATE ending because it has a greater number of oxygens than the rest of them, but not quite the greatest. The greatest amount of oxygens is going to be called perchlorate. ATE ending because it has the greater amount of oxygens, per prefix because it has the greatest amount of oxygens. If you can memorize just one of the versions of a polyatomic ion, you can easily figure out the rest by subtracting those oxygens and changing the ending and or adding a prefix. So just a couple of rules to remember when you're doing ionic nomenclature. The first element, which is the cation, will keep its own name. The second element or elements, which is the anion, the ending will change to IDE if it's just a single element, and if it's polyatomic, use the polyatomic name. Rule 3, make sure the charges are balanced. I'll get to that a little bit later, but we'll use subscripts to do the balancing. And the last rule, if the cation is a transition metal, then you name the charge. You're going to use Roman numerals to do that. If you don't know your Roman numerals, here's a quick little list you can copy down and use for later. Alright, let's try a couple of examples. Our first example is NaCl. I know this is ionic because sodium is a metal, chlorine is the non-metal, so I follow the ionic rule set. So the first element keeps its own name, so sodium is still sodium. Cl is chlorine. I want to change the ending to IDE since it's a single element by itself. So I make it chloride. So that compound is called sodium chloride, which is just regular old table salt. Next example, Zn3P2. Zn is zinc. Now that is a transitional metal, but it only has one ionic form, so I don't have to name a charge on that one because it's understood to be a +2 charge. P is phosphorus, so I changed phosphorus to phosphide. So that answer is zinc phosphide. Next example, NH4F. NH4 is a common polyatomic ion. NH4 is ammonium, so I just write ammonium. F is fluorine, so I change that to fluoride. So that's ammonium fluoride. Next example, CuCl2. Cu is copper. Copper has multiple ionic forms, so you want to state which version this is. So in order to do that, we need to figure out these charges. Chlorine is always a negative charge. So -1 times 2 gives me an overall charge of -2. So to balance a -2, I need a +2. +2 divided by 1 gives me +2. So copper's charge in this case is 2. So I put copper 2. Cl is chlorine, so again I change chlorine to chloride. So that is copper 2 chloride. Next examples, Ag3PO4. Ag is silver. Now silver is a transitional metal, but it only has one ionic form, which is a +1 charge, so I don't need to worry about naming it. I just leave it as silver because it's understood to be 1. PO4 is a polyatomic ion. PO4 is phosphate. So we get silver phosphate. Next example, NiPO4. Ni is nickel. Now we do need to name its charge because it has multiple forms. So in order to figure that out, we got to figure out the overall charge. We know phosphate is a -3 charge. -3 times 1 gives us -3, so I need a +3 to balance that out. +3 divided by 1 is +3. So this is going to be nickel 3, and then PO4 is phosphate. So that answer is nickel 3 phosphate. Next up, Cu2O. Cu is copper. We know copper is a transitional metal. We know it has multiple ionic forms. We got to name a charge. So we got to figure out what it is. Well, oxygen's in column 16, so that means it has a -2 charge. Well, oxygen's in column 16, so that means it has a -2 charge. 2 times 1 is -2, so you need a +2 to balance that out. +2 divided by 2 is +1. So that's copper 1. O is oxygen, so we change it to oxide. So copper 1 oxide. Last one, we got NH4 2SO4. This one has 2 common polyatomics in it, so we just got to name each one of them. NH4 is ammonium. SO4 is sulfate. So that's just ammonium sulfate. I hope this video helps, and good luck on your tests.